Hey, 7th grade. So in this next video, we're going to continue talking about how to solve quadratic equations. What I'd like you to do right now, just as a review from the last video, is I would like you to solve this quadratic equation right here using your quadratic formula. So you're going to solve the equation x squared plus 3x minus 28 equals 0. Go ahead and solve that using the quadratic formula. Click pause on the video right now, and then once you have the answer, click play again to check your answer, please. Okay, so if you solve this equation correctly, you should have got two answers for this. One answer, -7, and the other answer, +4. So if you got that, give yourself a pat on the back. Congrats. And now we're going to talk about a much quicker way to solve equations like this so that you don't have to use all of those steps in quadratic formula. Okay? So now you're going to learn a little bit of a shortcut, which many of you I know are fans of. So this next lesson is going to be, again, in your books. This is going to be from section 12.4, and we're going to talk about how to solve quadratic equations by everyone's favorite thing, factoring. Okay, so this is factoring to solve quadratic equations. Okay, so yeah, quadratic formula is really handy because it solves all quadratic equations, but it's not very convenient because it takes a lot of steps. So the reason we talk so much about factoring in our unit over polynomials is because it comes in handy when you're solving quadratic equations, because it makes it solving a lot quicker. So we're going to talk about how to solve a quadratic equation using what you know about factoring. There is one thing I want to talk about first before we get into some examples here, and that is what is called your zero product property. And this property, you probably already know it, but you've probably never really thought about it or given it a name before. So I want you to just imagine that you have two numbers. We're going to call them A and B. And so if I took A times B and I got a product of 0, so two numbers, A times B, and my answer was 0, think about for a second, what must be true about one of those numbers? If A times B is 0, then what has to be true about one of those numbers? Well, just based logically on what you know about multiplication, if you take a number times another number and you get 0, the only way to get 0 is if one or both of those numbers had been 0 originally. So we can say that if A times B equals 0, then A equals 0 or B equals 0. And that right there is what the zero product property says. Okay, if a number times another number is equal to 0, then either the first number is 0 or the second number is 0. Well, we're going to use that in solving our quadratic equations today. So let me jump ahead to a quick example so you can see how this zero product property actually works. So we're going to take the equation, and this isn't going to look quadratic at first, but bear with me. We're going to take the equation x plus 1 quantity times the quantity x minus 5 and set that equal to 0. Okay, so if this is a true statement, okay, if x plus 1, this quantity, times x minus 5, this quantity, is really equal to 0, well, then what has to be true? Well, just like this zero product property says, if this times this equals 0, then either the A value has to be 0 or the B value has to be 0. Same thing down here. X plus 1 itself is a number. So if x plus 1 times the quantity x minus 5 equals 0, then either x plus 1, that has to be equal to 0, or the other quantity, x minus 5, which itself is a number, has to be equal to 0. So based on that logic, if x plus 1 is 0, x would be -1. If x minus 5 is 0, then x would be +5. So this is an example of a quadratic equation. It doesn't look like a quadratic equation, but it's a quadratic equation that's in factored form. Okay, if we were to multiply this out and do some FOIL, we would get an x squared minus 5x plus 1x minus 5, which would look a lot more like a quadratic equation, okay, that we're used to seeing because it would have an x squared in it. So this equation here is already in factored form, and now that we know this zero product property, we can say what the two solutions would be. The solutions would be -1 and +5. Okay, so now let's go back to that problem I had you do at the very beginning of this video, and x squared plus 3x minus 28, we're now going to solve that using factoring as opposed to the quadratic formula. Okay, so we already know the answer is -7, +4, but now let's go ahead and talk about how you could do this using your factoring. So x squared plus 3x minus 28. We should know how to factor that. Let's review our basic factoring rules. When you have a trinomial, you need to look at the constant term, which is -28, and think about what kinds of numbers multiply to get a -28. Well, to get a negative, we know we have to have a positive and a negative. So we're going to put an x plus something and an x minus something. Again, a trinomial always factors into two binomials. Then you have to think of numbers that not only multiply to get this 28, but they need to have a difference, because these are different signs, of 3. So what factors of 28 have a difference of 3? Think about it for a second. That would be 7 and 4. And so now, which needs to be the positive? Well, if you combine these, you have to get a positive answer, +3. So that means the larger number needs to be positive. So we're going to have an x plus 7 and an x minus 4. Okay, and at first glance you may say, hey, well, our answer was -7 and +4. Why is this a +7 and a -4? Well, that's because we're not done yet. We've factored this into x plus 7 times x minus 4, but now we need to use that zero product property, just like we did here for number 1. So if the quantity of x plus 7 times the quantity of x minus 4 is equal to 0, then that means x plus 7 itself is equal to 0, or x minus 4 itself is equal to 0. Well, what would make x plus 7 equal to 0? If x were equal to -7, that would be true. And to get x minus 4 equal to 0, x would have to be +4. And so that's how we get our two answers of -7 and +4 using our factoring method. Okay, let's try a third example. So for this one, I want to solve the equation x squared plus x equals 12. Well, just like with quadratic formula, we want to get everything on one side before we start anything, so get it in standard form. So I'm going to subtract 12 from both sides. And that's going to give me the equation x squared plus x minus 12 equals 0. Okay, and now let's think, how does x squared plus x minus 12 factor? Again, your constant is a negative, so you know you're going to need a plus and a minus in your binomials. So we're going to have an x plus and an x minus. Think about factors of 12 and factors of 12 that combine to get a positive. This is a +1 right here. So think about that for a second. We would have to use an x plus 4 and an x minus 3 to get that. 4 times -3 is -12. 4 minus 3 is +1. And so now, based on that, what would our zeros be? What would our solutions be for this equation? Okay, don't leave your answer like this because we're not done yet. We haven't solved completely yet. Well, if x plus 4 is equal to 0, then x has to be equal to -4. So that's one answer. X is -4. Your other answer, if x minus 3 is equal to 0, then x has to be +3. So you might be seeing a sort of pattern here. You'll notice that every time we factor this, our answers are just the opposite sign of what you see. You can think of that pattern working that way. Yes, that is true, but also don't forget that it's because we're setting each of the quantities equal to 0 and solving that those come out to be that way. Okay, so we're going to look at one now where you can't just make the sign the opposite. You actually have to do a little bit of thinking and set it up this way. Okay, so that brings us to number 4. I want to solve the equation 2x squared minus 5x minus 12 equals 0. Okay, so this equation is going to be a little bit more challenging simply because your trinomial, we're already in standard form, but the leading coefficient this time is a 2 and not a 1. And so remember, anytime your leading coefficient is anything but 1, you need to first of all look for a GCF, which we have a 2, a 5, and a 12, so that really isn't going to help us. And then you need to use your slide and divide method. So to review slide and divide, we need to slide that 2 over to the 12 and do some multiplying there. So that's going to give us x squared minus 5x minus 24 equals 0. And then we'll factor that like normal. We have a negative 24. So again, we need a positive and a negative for our signs when we're factoring. And we need factors of 24 that have a difference of, this time this is a negative 5. So our larger number needs to be a negative. So what factors of 24 have a difference of 5? That's going to be negative 8 and positive 3. Do not stop there because we did slide and divide. We've already slid our 2, but now we have to divide by that 2. So don't forget this important step. We have to divide the 3 by 2 and the 8 by 2. So we end up getting x plus 3 halves factors back into 2x plus 3. And 8 over 2 is just 4, so we can leave this as x minus 4 is equal to 0. So that's how this factors using slide and divide. Well, now we want to actually solve this because this is an equation. So now we're going to use the zero product property, and we're going to set this quantity equal to 0. 2x plus 3 equals 0. And then this quantity equals 0. Well, the x minus 4 is easy. I know if x minus 4 is equal to 0, then x has to be positive 4. To get my other answer, I've got to do a little bit more, but not a lot. This is just a two-step equation. So to solve for x, I need to subtract 3 from both sides. So I get 2x is equal to negative 3. And then when I divide by 2, negative 3 divided by 2 is negative 1.5. So I get answers of 4 and negative 1.5 as my zeros for this problem. Okay, let's look at another one. These go kind of quick, so we're going to look at a few more examples on this clip than we have the last ones. So this would be number 5. X squared plus 6x is equal to 0. Don't be thrown off by this problem. Okay, this time we only have a binomial, and if you think back to, again, your factoring notes, feel free to look at those before you do this next homework assignment, because some of you might need to look back at your factoring methods. For a binomial, there's only one of two possibilities. Either it's a difference of squares, which this one is not. Okay, it's not a difference problem, first of all, and then 6x is not a perfect square. Or it's a simple factor out of GCF and you're done. Well, the GCF for this problem, if you have an x squared and a 6x, you know you can factor an x out of both those terms. So my GCF would be x, and I'd be left over with an x plus 6. X times x is x squared, x times 6 is my 6x, is equal to 0. Okay, now let's think about how the zero product property applies to this problem. If this times this is equal to 0, then again, either this first part, which is just x in this case, equals 0, or the second part, which is x plus 6, is equal to 0. Well, the first part is easy. If x is equal to 0, then x has to be 0. So this is one case where 0, the number 0, is actually one of your zeros. Okay, this is going to touch the x-axis at the origin, at 0, 0. The other, x plus 6 equals 0, just means x could also be negative 6. So your two solutions for this problem, 0 and negative 6. Okay, there is one more that I want to try. So this will be the last example, number 6. 2x squared minus 96 is equal to 16x. Think about what the first thing we need to do is, and that would be get this in standard form. So I want to subtract that 16x from both sides. And don't forget to put this in the middle because that's going to end up being our linear term, our middle term. So this becomes 2x squared minus 16x minus 96 is equal to 0. Now let's think about how you can factor this trinomial. Well, this time we have a 2, a 16, and a 96, which are all even numbers, so I can factor out a GCF on this one. I can factor a 2 out of every term. So that's going to leave me with x squared minus 8x minus 96 divided by 2, you'll get a minus 48, is equal to 0. Okay, now let's think about this. If 2 times all of this is equal to 0, what has to be true? Well, either all of this has to be equal to 0, or the 2 has to be equal to 0. Well, obviously 2 is not equal to 0. So really, when you factor just a number GCF out in a quadratic equation, you don't really need that number there anymore. Okay, we know that 2 obviously is not going to give us the 0 over here. So all I'm concerned about now is x squared minus 8x minus 48. That's the only part I need now. You can also think about, just to keep this a true equation, dividing both sides by 2. So if we were to divide by 2 here and here, these 2's would cancel each other out. 0 divided by 2 is still 0. So either way, you end up getting x squared minus 8x minus 48 is equal to 0. That's what we're concerned with, and so that's what we'll factor. X squared minus 8x minus 48. Why don't you try factoring that on your own? Click pause if you need to. And so for this one, you'll again have opposite signs, so a plus and a minus. I promise on your homework they won't all come out to be plus and minus. Factors of 48 that need to have a difference of 8, and the larger number needs to be a negative. So that's going to be an x plus 4 and an x minus 12. Okay, 12 times 4, 48, and then combine those, you get your negative 8. So what does that mean in terms of our answers? Well, if x plus 4 is equal to 0, then x has to be equal to negative 4. And then if x minus 12 is equal to 0, x has to be equal to positive 12. So your answers for this one are negative 4 and positive 12. Okay, so again, this is another method for solving quadratic equations. The nice thing about it is it's pretty quick as long as you know how to factor. It's a lot quicker than quadratic formula. The downside is it doesn't always work because you should know that not every single trinomial or binomial factors. So when polynomials do factor, this is a really good method to use for solving these quadratics. So go ahead, go back through this if you need to. Start on the 12.4 homework, and I will see you for the next video. Thank you. Have a nice day. You're all wonderful people.